Hey guys, welcome to the slope video of our linear equations unit. At this point, you should have already made your way through rate of change and unit rate. So we're going to keep adding on to that, talking about slope today. So you're going to see a few things within this one that are going to be a little familiar. You're going to see us use rate of change. I'm going to go ahead and break the news to you now. Rate of change is slope. So we are doing something similar to what we've already been doing. Now, on these notes, we're going to actually be going back and forth on the page quite a bit, so we're not going to necessarily go in order of what's on this sheet. So, case in point, we're going to go ahead and start on the back page. So if you'll flip over your page, just so you know that this will be page 28 in your notes, and when you go to put them in, just title it Slope Notes and create an anchor tab and put them in your notes that way. We're going to start here. So at the beginning of this topic, you should have watched a video called Slope Dude. And as he went through, he talked about the adventures of Slope Dude, of his path of when he went skiing. And his path looked a little something like this. Now, his pathway shows every single possible slope that you will see here during our class. When he was going uphill, he said puff puff positive, so that was a positive slope. As he was going downhill, he said nice negative, so that was a negative slope. The best way for me to compare these is I want you to think back to money. When we're talking about money, and you've seen it on the stock exchange, you've seen it in real life, when we talk about money and you're gaining money, you see the graphs tend to go up like this from left to right. Now when we're talking about losing money, which nobody likes to do, you see the graphs going downhill like this. So that's the loss of money, so that's our negative slope. So a positive slope is always going up from left to right. Our negative slopes are the same thing, but they go down from left to right. And like I said, the easiest way, I think one of the ways that most people understand, is to think in money terms. Then we had our zero slope, which was a straight horizontal line across. A zero slope can happen anywhere on our graph, but it's going to be a horizontal line going through. And then lastly was that word that they said we don't ever want to say, undefined. And that's going to be our vertical up and down lines. Okay, so what I want to go ahead and tell you now, and we'll see it here in a little bit, is that the slope is not the measure of a line. It's a measure of the steepness. So it's not the length, but the steepness of a line. So when we have a positive steepness here, we have a negative steepness here, we have a zero steepness here, and we don't have any steepness. It's an undefined, so that's why our slope is undefined. So we're going to see that come into play here a lot in a second, but I wanted to go ahead and touch on that from that Slope Dude video. Now going back to the front, we're going to talk about rate of change again. Okay, rate of change is a ratio. Okay, remember ratio means fraction of the amount of change
Teacher.
Sorry about that noise from the speaker. Like I was saying, rate of change is a ratio of the amount of change in the output. Remember, we talked about this during our functions. Output means y. Amount of change in the output to the amount of change in the input. And input is our x. So the way we show this is the change in y over the change in x. In math, the triangle also represents the term delta. Delta represents change. So the change in y over the change in x. And we saw that when we got to our tables that we were doing in our rate of change unit. So it says the table shows the distance of band marches over time. Is the rate of change in the distance with respect to time constant? What does this rate of change represent? So remember we talked about, okay, what's the change between 1 and 2? It's a positive 1. Change between 2 and 3, positive 1. 3 and 4 is also positive 1. What was the change between 260 and 520? It's positive 260. The change between 520 and 780 is a positive 260. And 780 and 1040 is a positive 260. So if we take that change in our y, which was 260 positive, and put it over our change in our x, which was a positive 1, then we see that our rate of change is 260. Now, I don't know if you remember from our previous video when we were talking about K, which is our constant of proportionality and constant of variation, we said K is equal to something else, what we know of as M. And I'm going to go ahead and kind of preface this now because we're going to start getting into it into our non-proportional representations. We've been used to seeing this equation here. We're going to start seeing this equation. Well, this equation is the same as this one because we've been saying that it has to have a 0 right here. Now, if these are the same equations, then that means these are the same pieces, these are the same x's, and this k and this m are the same thing. So our constant of proportionality, our constant of variation, our rate of change, unit rate, and slope are all the exact same thing. Okay, and we're going to see how the only difference is that m does have a different way of solving it, and so I'll show you that here in a second. So keep this in mind. Rate of change, we look at that change in y on top of our change in x. So we're going to go ahead and flip it over to the back, and we're going to start right here where it says key concept slope formula. Now, like I said, we're used to finding k. K is the same thing as m. M represents slope. M is our slope. Now, there's a formula that you will actually get on your reference chart that is the slope formula. Slope formula is m equals y2 minus y1 over x2 minus x1. Now, the difference in these 1s and 2s is it's saying that we need to take 2 points. So we have 1 point xy and another point xy. Now I want you to look. We're doing a y minus a y value. So here's representing our change in y. We're doing x minus x, which this represents our change in x. So this right here is the same thing as our change in y over our change in x. We are still doing the exact same thing. This time we just need to take two values, subtract those y's, subtract those x's. That gives us our slope. So let's go ahead and look at this example here. They've given us 2 points. Now, if we were to do it from a table is a list of points that are on a given line. We could take any 2 points and still do the same formula. So we said our slope formula is y minus y over x minus x. Okay, y2 minus y1 over x2 minus x1. I want to go ahead and say this now. Whatever y you choose to go here, the corresponding x value must go underneath it. Okay, so for instance, we had the points -1, 0, and 3, -2. It does not matter which one you choose to go first. So for instance, I'm just going to choose the -1, 0. So I need to take my y value of 0. I need to subtract my other y value. So my other y value is this -2. So I'm going to subtract -2. Now underneath I need to go x minus x. So the x value that goes with the 0 is -1. So I'm going to have -1 go underneath, minus, I need to subtract the x value that goes with this -2, which is a 3. Now I'm going to go ahead and say this now as well. Whenever we go through and solve for slope, you always want to keep it as a fraction. And we'll get to it here in a second when I show you the other way to find slope. Fraction is going to help you keep it. Now, of course, if it's a whole number, you can go ahead and simplify to that whole number, but you need to be able to know how to convert that whole number into a fraction as well. So 0 minus -2, 0, subtracting a negative is the same thing as adding a positive, so 0 plus 2 is 2. -1 minus 3 is -4. This simplifies to -1/2. So my slope that both of these points lie on is a slope of -1/2. Okay, so let's try it with this one. I'm going to go ahead and take one of my y values. So I'm going to take this -2. I'm going to subtract the other y value, which is 1. Put that on top. Whatever x value goes with this -2, well, that's a -2, minus the other x value, which is -2. Okay, so we're going to simplify. -2 minus 1, 3. Okay, so now that I've done the y values, I'm going to do the x values. So once again, I'm subtracting negative, which is the same thing as adding a positive. -2 plus 2 is 0. So here's where we're going to run into our first issue. we have 3 over 0. So at this time, take a second, and then in your calculator, I want you to type in 3 divided by 0. When you do that, you should end up getting an error, and it says something about dividing by 0. You are not allowed to divide by 0. So here's one way I want you to think about it. I'm going to give you 3 different fractions, okay? 1/2, 0 over 2, 2 over 0. Does it make sense that you can have one of two things? Well, yeah. If we're talking about we have a crate that has 2 gallons of milk in it, I can have one out of those 2 gallons of milk. Can you have 0 of two things? Well, that's also possible. I can have 0 gallons of milk out of the 2 that I'm supposed to have inside of a crate. But does it make sense to have 2 of nothing? You cannot have 2 things of 0. Therefore, this right here is an undefined slope. If you ever get that error, or you get a fraction over 0, your slope is undefined. Okay, so take a second, pause the video, and I want you to do these 2 right here. Okay, now that you've gone and paused it and you've done these examples, what we're going to do is we're going to go ahead and do the example. So 2 minus 2, there's my 2 y values. The x that goes with that y is a -3. X that goes with this y is a 2. 2 minus 2 is 0. -3 minus 2 is -5. Now this is what we talked about. Is it possible to have 0 of 5 things? It is. 0 divided by -5 is 0, so our slope is 0. Last one, 3 minus -1. Those are both my y values. X that goes with 3 is 1. Minus x that goes with -1 is 4. 3 minus -1, subtracting the negative, same thing as adding a positive. So 3 plus 1 is 4. 1 minus 4 is -3. Our slope is -4/3. Alright guys, at this point in time, if you have any questions on how to solve using the slope formula, pause the video, raise your hand, and let me help you out, because if you get this, then you can move on. If you don't, I want to make sure we have this before I show you your other method. Alright, so once you've done that, what I want you to do is I want you to go back to the front of your notes, and we're going to look at the other way to find slope. The other way we can find slope is on a graph. So we can use that slope formula on a graph, on a table, or if we're given points. Slope formula works no matter what you're given. What I'm going to show you is another way you can do it on the graph that's going to be a lot quicker. It's going to be a lot quicker, but it only works when it comes to a graph. And this is called rise over run. Now I want you to think on an x and y axis. What directions do rise represent? Well, that represents up and down, because that's a rise, and run represents right and left. So if you put up and down, that is also what we use for y. Left and right is x. Notice that rise over run is y over x. Okay? So the best way I can think of this is think about when we did Pythagorean theorem. We needed to find the length of this piece here, so we counted how far over and how far up we did, and we solved using Pythagorean theorem. Now, we are not doing Pythagorean theorem here, because remember, Pythagorean theorem finds the length. Slope is not the length, slope is the steepness of that line. But you will use the method in which we counted over and up to create a right triangle to represent rise over run. So for example, we're going to go right here. I'm going to look at this line, and I need to find 2 perfect points that this line goes through. So I see that this line goes through the point 2, 5. So I'm going to go ahead and put that point there. And I see that it goes through the point 0, 1. Okay, so once again, we know the 2 points, so we could use our y2 minus y1 over x2 minus x1. But in this case, I want to use rise over run. So I'm going to start with my y value. We read a book going left to right, so I'm going to read this line left to right. So going here to here, I have to go up or down first. Well, to get from this point to this point, I must go up. Okay, so I have to go up 1, 2, 3, 4 points. So my rise is a positive 4. Once I've gone up 4, now I'm going to look at my run. I have to go right 2. 1, 2. Right is a positive number, so our run is positive 2. We can simplify positive 4 over positive 2 as 2. Our slope for this line is 2. Alright, we're going to do the same thing on this one. We're going to pick two random points. I'm going to choose the point 1, 3, and let's go 3, 1. Alright, so remember we're going to go rise over run. Rise is up and down, run is left and right. So to go from left to right, I must go down first. Now I go down 1, 2. So down 2 is a negative 2. Now I got to go right, so I'm going to go right 1, 2. So since I went right 2, that's a positive 2. This simplifies negative 2 over positive 2 is a negative 1. My slope is negative 1. Alright guys, on the back are two examples. Go ahead and pause the video now, and I want you to try these two examples. Alright, so you should have had a chance to go. I'm going to go ahead and set up for my rise over run. My rise is a positive 2. My run is a 1, 2, 3, 4, 5. Positive 5. So that means your slope should be 2/5. Looking here, go ahead and do rise over run once more. My rise is a negative 2. So I'm going to have a negative 2. My run is 1, 2, 3, 4, 5, 6. So positive 6. Negative 2 over 6. I'm sorry you didn't see that. Negative 2 over 6. That simplifies to negative 1 over 3. There is my slope. Alright guys, that's a quick run through on how to find slope. If you have any questions, please raise your hand. This is a very, very important piece when it comes to linear equations. So if at any point in time any of this does not make sense, please raise your hand and I will be there to come help you. Alright guys, have a good one.